Welcome to the first video in our foundational training series designed to introduce new users to Larsa 4D. In this series, we'll walk through the user interface and key components of the program to help you get started with confidence. In today's tutorial, we'll explore a complete concrete bridge model to give you an overview of the application and get you familiar with Larsa 4D's graphical user interface. Larsa 4D is a general-purpose finite element modeling application developed in collaboration with leading bridge design engineers. It includes specialized tools for non-linear, segmental, cable-supported steel girder, and other complex bridge structures. Now, let's explore the basic layout of the application and walk through some of the key features you'll be using. When you launch the application, the welcome screen appears. Here you can check the latest version, explore product videos, view upcoming trade events, and find information on support and training. Let's close the welcome screen and move on to our example model. At the top of the interface, you'll see the main menu, followed by the toolbars, and to the right, the Explorer panels. From the main menu, you can access a wide range of commands, spreadsheets, and tools to model, analyze, and design complex bridge structures. A key part of this menu is the Input Data section. It includes commands for importing material and section properties, adjusting input units, and managing project databases. The toolbar in Larsa 4D provides a range of tools that help you interact with your model visually and efficiently. It's located just below the main menu and includes sections for view control, navigation, selection, and display settings. You can quickly switch perspectives using the Change View buttons. Click 3D View to return to the default isometric view. Use front plane, side plane, or top plane to switch to standard orthogonal views aligned with the global axis. To adjust the viewing angle incrementally, use the Rotate Left, Rotate Right, Rotate Down, and Rotate Up buttons to rotate the model around the vertical or horizontal axes. For freeform navigation, use the Rotation and Pan tools. The Rotation tool allows you to rotate the model in 3D space by clicking and dragging. The Pan tool lets you shift the view horizontally or vertically, keeping the zoom level unchanged. To zoom in and out in the model, scroll the mouse wheel for smooth zooming. Use the Zoom Window tool to draw a box around a region you want to zoom into, or click the Zoom In and Zoom Out buttons on the toolbar for step-by-step zoom adjustments. The selection tools let you isolate parts of the model for editing or analysis. Select or unselect objects by clicking or dragging a selection box. Filter by element type, like joints, members, or tendons, for targeted selection. Use the option to hide unselected elements for a clearer workspace. The Select Special tool allows you to select or unselect based on filters such as group membership or element properties. You can also use keyboard shortcuts: S to select all, U to unselect all. Additional shortcuts are available in the menus and help documentation. Larsa 4D's Explorer panels help you navigate your project efficiently. The Construction Stages Explorer is used to set up stages and steps for a staged construction analysis. The Results Explorer allows you to browse results from analyzed load cases. The Structure Groups Explorer lets you organize your structure into groups, which can be used for extracting results, defining construction steps, or creating steel design groups. To create a structure group, select the desired joints and elements, unselect the rest, and click Add Group. You can organize groups into folders and use the section commands to quickly select or unselect them. The Model Data Explorer is where you can add new elements and modify the model geometry. For example, after selecting column members, you can update their orientation angle. Pending changes appear in bold and are applied by clicking the checkmark at the top. The Load Cases Explorer allows you to create and manage load cases and combinations. Click Add Load Case, then double-click any item to edit it through the spreadsheets. You can always customize the visibility of the Explorer panels, and you can show or hide the Explorer panels using the Show Explorers option under the View menu. Now, let's run the analysis. Under the Analysis menu, you'll find all available analysis types. For this example, we'll perform a nonlinear static analysis. When you start the analysis, the model will be saved, and a window showing the status of the analysis will pop up. Once the analysis is complete, let's start with graphical results. Select the Member Forces tool, choose a direction like MZ, and select a result case from the Analysis Results Explorer to display the moment diagram in the local Z direction. The color legend on the right shows the minimum and maximum values. To customize the display, right-click in the Graphics view and choose Show, or access the same options through the Graphics menu. For instance, we can hide shell elements to better visualize girder moment values. You can also extract results into spreadsheets via the Results menu or by right-clicking on a result case in the Results Explorer. Use the Control key to select multiple result cases. Each selected case will be listed in the spreadsheet rows. When you envelop a force direction, such as FZ, the software compares all the selected cases and identifies where the minimum and maximum forces occur in that direction. In the spreadsheet, the rows will alternate between the minimum and maximum results for each joint or element. The first row shows the result case that produced the minimum, most negative force in FZ. The next row shows the result case that produced the maximum, most positive force in FZ. Alongside these, the spreadsheet also shows the other force and moment components, just as they were at the time when the extreme FZ value occurred, giving you a full picture of the loading condition. You can adjust how many segments are used when displaying member end forces. Go to Results, Results Display Settings, and set the number of segments, for example 5. This divides each member into 6 stations, numbered 0 through 5, for more detailed output. Finally, let's take a look at the deformed model in the Graphics window. The deformed model visually shows how the structure responds under the applied loads, displaying the displacement shape based on the analysis results. By default, the deformation is shown with a scale factor to make the displacements easier to see, even when the actual deformations are very small. You can adjust the scale factor using the slider located at the bottom right corner of the application window. Increasing the scale factor exaggerates the displacements, while decreasing it brings them closer to their real-world size. You can also switch between different result cases using the Analysis Results Explorer to see how the structure deforms under different loading conditions. For a more dynamic visualization, you can enable animations in the Graphical Results Options window, allowing you to see how the structure transitions into its deformed shape over time. That brings us to the end of this introductory tutorial. Thank you for watching. We invite you to visit our website larsa4d.com for more training videos.